Okay, during the break, I had a lot of questions over how to do the worksheet and the test and about universal gravitation. I'm not sure if the disconnect was in the actual equation or if it's how to put it into the calculator, because we're having to use scientific notation because of the extremely large or the extremely small numbers. So I'm going to give another quick overview of universal gravitation, okay? And then at the end, if that is not what the problem is, I can also help you on how to put in the equations or the numbers into your phones or calculators. So, universal gravitation. Let's say we have two objects on Earth, whether it be two bowling balls like I have it drawn, or you and your desk, you and your pencil, you and your phone over the last week, you and your bed, okay? Between all objects in the universe, there is a gravitational pull between all objects, okay? They're all happening at the same time. They're all happening right now. Except the reason you don't have stuff hurtling towards you to stick to you, like in your imagination, is because while that gravitation is occurring between all objects and you right now, it's also happening between the Earth and you. So let's say we have two bowling balls. If they weren't on Earth, okay, and there was no other gravity except these two bowling balls, they would be moving towards each other. There's a gravitational attraction between all objects. But because they are sitting on the Earth and the amount of force gravity applies is proportional to mass. Well, since the Earth is so much more massive than anything that's sitting on the Earth, the gravitational force of the Earth is greater than the force between these two bowling balls. Therefore, the balls are stuck to the Earth. There's not enough gravity between them because the masses are small and the Earth's mass is so much larger. Okay? It's there. There is a gravitational force between you and the person sitting next to you. It's there, except you don't realize it. You don't feel it because Earth's gravity is so much larger. So, our main equation. The force of gravity between any two objects is equal to the constant g times the mass of the first object multiplied by the mass of the second object divided by the distance squared between them. Okay, again, this is not just planet-size objects like the Earth and something on the surface. It's happening between all objects. It's happening at a subatomic level. It's happening between electrons and protons. It's happening between everything around you, and it's also happening on a universe scale with the suns, the stars, the planets, the moons. You get the idea. So, this is the main equation. G is always going to be 6.673 times 10 to the negative 11. It's not going to change. It's always going to be this. Okay? So wherever I write G, this is what you're going to put in wherever G is. Okay, everything else. When we're talking about objects that are not planet size, okay, this is the force of gravity between the two objects. When it's talking about something that is planet size, like a person standing on the surface of Earth, another way to describe this is weight. So F of G, weight is the amount of gravity that Earth is pulling down on an object. So when you step on a scale, what you're measuring is how much the Earth is pulling down on you. And it's dependent on mass and indirectly proportional to the distance between you and the other object. Okay, does that make sense? So if I were to set up one of these on the worksheet, if I were to take, let's do number 6. And then I'm going to come back and talk about another aspect of this. So number 6 on the worksheet. Oh, before I go too much further. When using this equation, force must be in newtons, mass must be in kilograms, and the distance has to be in meters. So on number 6, it tells you that the distance between two separate objects of equal mass is 2 millimeters. Excuse me. The distance is 2 millimeters. This has to be in meters. So the first thing you're going to do is you're going to change that to 0.002 meters. For the test, I didn't give you any that have to be converted. I was nice. Figured you had enough of other stuff to figure out how to push in. I didn't try to trick you. So here's our equation. Mass 1, mass 2 over the distance between them squared. The distance between two equal objects is 2 millimeters or 0.002 meters. If the gravitational force between them is 0.0104 newtons, find the mass of each object. So we have this equation. It gives us this. It gives us the distance between it, and we know g. We're going to solve for the mass. In this case, these two masses are equal. So another way we could have written this is this way, which is, since these two are equal, mass 1 times mass 2 is the same as saying mass squared. And we're going to solve for mass. So it gives us Fg. We know what big G is. We're going to solve for the mass. And we know the distance between them. So now I'm just going to rearrange this to isolate M2 on one side of the equation. So 0.0104. I'm dividing on this side, so I'm going to bring it over to the other side and multiply. Okay. G is multiplied on this side, so I'm going to divide this side by G. All I did was rearrange this equation. Now, this is m squared. I don't want to square it, so I'm going to square root both sides, which cancels out the squared on that side and makes this side the square root. If you punch this into the calculator correctly, mass should be 25 kilograms. Make sense? Okay, everybody got it? Now, one part about this equation, Fg equals G, mass 1, mass 2, divided by radius squared. Okay, that's the only equation we're using. We're just manipulating this same equation. We know from Newton's laws that force equals ma, Newton's second law. Okay. When we talk about the force of gravity and calculating force, it was mass times g, where g is acceleration due to gravity, right? And up to this point, g has been 9.81 meters per second squared. It's up on the board. It's behind the screen. It hasn't changed all year. And I keep saying it's constant. But Here's where we get G. So if you take this equation and take one of the masses out, that's this one, okay? And this one is insignificant. I mean, compared to the mass of the Earth, by the time you add an 80 kilogram or whatever mass, it's going to be so insignificant that we're not even going to be able to, it won't even register on the answer, okay, when you work this out. But what's left if we take M1, which for all practical purposes can be excluded, what's left is big G, mass of the second object, which in this case is the mass of the Earth, of planet Earth, divided by the radius of planet Earth squared. So if you take G, which is 6.67 times 10 to the negative 11, you multiply it by the mass of Earth, which is 5.98 times 10 to the 24th. It's on the front of your worksheet. And divide by the radius of the Earth, which is 6.38 times 10 to the 6 meters squared. What you're going to get is the force of gravity, in this case, is going to be 9.81 meters per second squared. So what I'm saying is this mass is this mass, but it really doesn't make a difference because it's so small compared to the mass of the Earth. This part is this part. So if you plug in the values for Earth on this part, you're going to get 9.81. If you put the mass of the moon and the radius of the moon here, you're going to get acceleration due to gravity on the moon. And it'll be a lot less than on the Earth because the moon is much smaller than the Earth. Does that make sense? So if you were doing a question like number 8 on your test, I will help you with number 8. The mass of a newly discovered planet is 4.4. So the mass of a newly discovered planet, so the mass of the planet is 4.4 times 10 to the 25th kilogram. What is the radius of the planet to have the same acceleration due to gravity as Earth? So to make the F of G 9.81, which it is on Earth. Acceleration due to gravity. So be 9.81 G M1 M2. We're not even going to talk about that. Okay. So like right here, you're going to put the mass of the newly discovered planet, 4.4 times 10 to the 25th, divided by r squared, and it wants to know the radius. That's what you're solving for. You have everything you need. You just have to solve for r. So r is going to equal the square root of G times 4.4 times 10 to the 25th divided by 9.81. This and this is the same equation. I just took the r squared over to this side, and I brought the 9.81 back over to this side. And then to get rid of the squared, that was the r squared, I took the square root of each side. You want me to step through it? How I rearranged it? What?
Yeah.
Okay, not a problem. So Fg equals G, the mass of the new planet, the radius of the new planet. I want to solve for this. So the first thing I do is I take this, which I want to isolate, over to here. So Fg times r squared equals Gm. Okay? Now, I want to isolate this r, so I'm going to take this over here. So r squared equals, I'm multiplying on this side, so I'm going to divide each side by Fg. Now I want to get rid of this square root. So I take this square. So I take the square root of each side. This squared is canceled out by the square root, leaves me with r. And this side is G mass divided by the force of gravity, which in this case, G is 6.673 times 10 to the negative 11. Your mass was the mass of the planet, the newly discovered planet, and your F of G was 9.81. Make sense? So I'm only using, like I said a while ago, that part of the equation. But that will be the answer to number 8. Okay. So, just looking at the back, hopefully y'all have taken a stab at the problems on the back. Does anyone have a specific question? Okay. Is anyone's problem with this due to not understanding the equation, or you're having problems putting it into the calculator? Speak up. Did that seem to help some? Okay. For those who have already taken the test, if you want to retake the test, retake it. The test is embedded in the tab, or it's also attached to the testing tab. Take the test again, and send me your answers, and I'll replace them. I'll take the higher of the two scores. Okay. If you have not taken the test yet, DMAC is open. You can go in and take the test. It has to be taken by Friday, or if you want to retest, I need the answers sent to me by Friday. Okay. Wednesday, we're going to start the new chapter. We're not going to get through the new chapter before finals. So your final in this class will go all the way through universal gravitation. So it'll be intro to physics, motion in one dimension, Newton's laws, and motion in two dimensions. Okay. Any questions, or did anybody have any questions on how to manipulate the equation? All good? Okay. So